Okay guys, so in this video I am going to walk you through a few thoughts that I have about types and why I think types are the best thing ever. So let's just get into it. Now, there are many reasons to love types, but my personal favorite reason to love types is that it makes my program much simpler. That's the number one reason. The second reason, which I think is also very valuable, is that it makes things very easy to refactor, because when you have a compiled language with a good typing system, changing names on variables and classes and methods and it becomes super trivial because the IDE gives you a lot of help. Just having a compiler that can use a really powerful type system is going to help a lot. And you may not know this, but a lot of the larger companies such as Google and Facebook and so forth, who are using a lot of JavaScript, which is a loosely typed language, are actually enforcing a lot of their projects to use things such as Flow and TypeScript, because typing is very time saving in large projects. But let's, in this little video of mine, actually walk through a case for when I think types can be extremely powerful. Now, here we have basically some code that illustrates what I believe to be a very common class that you're going to use or to create in almost every project that you build is a user, right? So let's look at what I call a bad user. So this bad user class just has a user ID, a first name and a last name, which are two strings basically, and it has a very simple constructor and just a bunch of getters. Easy peasy. This is, in my opinion, the sort of code that I would expect a junior developer to write. And it's not just a junior developer, I would actually say that mid-level developer, like most developers that I see write fairly standard Java, or this is in Java, but this is actually very common in most languages that have a typing system. You'll see this code in C# as well. Now, what's the problem with this? Well, there's not really any problem with it, but this is what I would argue a little bit of a brittle implementation, because the thing with having primitives or use primitives as your go-to to basically store your information or store your data in your program is that what you're doing is that you are now saying to the rest of your code that, hey, this first name can be any string. This last name can be any string. This ID here, it can be any UUID basically. And the question is if you intend that to be true or if you don't intend that to be true. And I'll make this clear by looking at how a good user works. So a good user, per my definition, has this structure. So it has a user ID that is of the type user ID, and it has a username of the type username. So what's the big hoo-ha with this, Frederick? This is basically the same thing, right? No, it's not. This is there's a world of difference here. If you tell me that you expect a good user to have a user ID of the type user ID, then you have explicitly said that this is a semantic difference from what the bad user has. UUID is not user ID. User ID is something explicit that I have declared, and it has some, and this will be clear in just a moment. Just bear with me. The same thing for username. I have explicitly said that I want a username of the type username. This is not just any string, because bad user, if you just say that it's going to be a string, first name can be anything. It can be null, it can be an empty string, it can be anything, but a name usually has some rules attached to it. So a first name usually has a few letters in it, but if you just give me a string, it could be an empty string. Maybe that's what you want. That's usually not what I want when I declare somebody's first name or somebody's last name. So let's look at the types. Let's look at username. And here I hope we can start to see some of the power of having a type for the thing that you want. So under the hood, username expects a string of first name and a string of last name. But as you can see here in the constructor is now checking these two primitives if they're null, and it's making sure that the name, because in our code here we say that a name has to be at least 2 characters long, and we also have some other rules saying that, hey, we don't allow, say, Swedish letters, and then we instantiate our object. What just happened is that we have now enforced a set of rules on our username. And why are we doing this here? Well, because this is the best possible place for you to validate that the data that you are receiving, the first name and the last name, are in the correct format and they abide by the rules of the system. This is extremely powerful. I'll show you, this will make sense in just a moment. Then we have user ID, which just takes in a UID of value, and all it has to do is that it has to check that, hey, it's not null, and then instantiate it. And what's even more beautiful is that you can actually now put, say, a static method or something like that that just creates a random user ID, and this is just a convenience method that I really like when I'm dealing with IDs of any sort, because sometimes you want to have a random ID just to because if you haven't saved something to the database, maybe you're creating an object for the very first time, then this is a very nice thing to do. But let's have a look at main again and these comments that I kind of just glossed over earlier. So in the scenario of the good user, all I have to do is say that, hey, this service here, I want to get my user by the full name of that user. And if I this method now takes a username, a type of username, and I give it foo and bar. This is going to work perfectly. Even if I were to do this, it would be the best thing ever, because now the username internally, as we saw earlier, this will actually throw an exception for me. And that's exactly what I want, because I want to be able to create a username and then have all the rest of my code feel secured in that if you are giving me a username, I can assume that the string is going to be in the correct format in accordance with the rules of the system. In other words, it's going to be at least 2 characters long. It's not going to be null. First name is not going to be null. Last name is not going to be null. And all these rules that you saw in the constructor of username. This is not true for bad user, because bad user only takes 2 strings, and these strings can be anything. And as you can see here in our system, we have said that a first name has to be of the type, has to have at least 2 characters, and we are inputting a first name here that is just 1 character. And here we have 2 characters, but there's an illegal character in our string. So what happens is that because bad user isn't checking that the values that represent the first name and the last name are correct at the instantiation, everything else has to do it for it. If we go into this little fake service of mine here, just pretend that these are database accesses for now. But as you can see, when I want to get the bad user by its full name, this method would, in theory now, if it has to check, it has to do all the checking that you saw in here. And every single method, service, whatever you're creating, the rest of the entire program needs to check these values to make sure that they follow those rules in some way. And although you could want that in some scenarios, I argue that this is so much more elegant. I really like this, because all my good user function here, or method, basically needs to do is that it says, okay, give me a username. All it has to do is to check that this is not null, because it could always be null. And if it's not null, we can just trust that it's going to work, because we know that good user uses a username, and username takes care of making sure that a username follows the rules of the system. This is why I argue that if you can use a type, create a type, don't use primitives. Use primitives only when you absolutely have to. Types are very, very powerful. Have a great day.